In this second part to section 5.2 about probability rules, we're going to focus on making two-way tables or Venn diagrams that we can use to model chance processes, and then we can use those to help calculate the probabilities involving two events. This example that we're going to go through is also the example that you'll see from the textbook, so you'll have to decide if you want to watch it again, and it might help. Maybe they'll say something different. So when we're finding probabilities involving two events, a two-way table can display the same sample space in a way that makes the probability calculations easier. So if you open your book to page 309, we're talking about the probability of pierced ears. So on page 309, it says, students in a college statistics class wanted to find out how common it is for young adults to have their ears pierced. They recorded data on two variables, gender and whether the student had a pierced ear, for all 178 people in the class. The two-way table below displays the data. So, suppose we choose a student at random from the class. Find the probability that the student, A, has pierced ears, B, is a male with pierced ears, and C is a male or has pierced ears. So we're going to define event A to be being a male and event B to having pierced ears. So for part A, the probability that a person has pierced ears would be in the column that is yes. So right here, the column that has yes, there were 103 students out of a total of 178 that had pierced ears. So the probability of pierced ears, or the probability of B, is equal to 103 out of 178. For part B, we want to find the probability that we have a male with pierced ears. So if we want to find the probability, okay, sorry about that. So the probability of A and B, the probability of being a male and having pierced ears. So we look at the intersection for the male row, so yes for pierced ears, and yes, or male for gender. There were 19 males with pierced ears, so the probability of A and B would be 19 out of 178. Letter C says the probability that they are a male or they have pierced ears. So this is different. So probability of male or pierced ears would be the probability of A or B, since there are 90 males in the class and 103 individuals with pierced ears, but 19 of those already are males with pierced ears. So we can't count those twice. So the probability of event A or B, we take the 19 plus the 71 plus the 84 out of 178. We make sure we don't count the 119 twice. Don't take 103 plus 90. We don't want to count this one twice. So here's some general rules. We cannot use the addition rule for mutually exclusive events unless the events have no outcomes in common. So if you look at this Venn diagram, which hopefully you've seen these before, if this box represents the sample space, this blue circle represents event B, the yellow circle represents event A, the outcomes that overlap are the probability of A plus the probability of B. The probability of event A and B, males and pierced ears, was 19 out of 178. They overlap. The probability of having pierced ears, the whole blue circle, is 103 out of 178, and the probability of event A being a male was 90 out of 178. This 19 in the middle overlaps and belongs to both events. So if we have two events resulting from some chance process, we take the probability of A or B is the probability of A plus the probability of B and subtract out the probability of having both A and B. Remember, if they're mutually exclusive and don't have anything in common, then we can add them together. Because Venn diagrams have uses in other branches of mathematics, some standard vocabulary and notation have been developed. The complement, A sub C, contains exactly the outcomes that are not in A. So if this is our sample space, this circle represents event A. Everything outside of A is the complement to A. Events A and B are mutually exclusive or disjoint because they do not overlap. That is, they have no outcomes in common. So this would be what the Venn diagram looks like. The intersection of events A and B, and we use this A with an upside down U for B, that's an intersection. It's a set of all outcomes that are both events A and B. A union of events, A union B, is a set of all outcomes in either event A or B. So union is actually or. Intersection is and. So intersection and union or. To keep the symbols straight, remember U for union and upside down U for intersection, or N. So recall the example on gender and pierced ears. We could use a Venn diagram to display the information and determine probabilities. So remember, event A is being a male, and event B is having pierced ears. So if you take and make this a Venn diagram, the probability of event A, which is being a male, there were a total of 90 people, or I'm sorry, a total of 190 males, 71 did not have pierced ears, 19 did. For event B, which is having pierced ears, there were a total of 103 that were yes, 84 of them were female, 19 were male. So this is males, this is pierced ears, they overlap with 19 people. Notice the 4 out here as well. The 4 represents the people that don't have any of those qualities. You can see the region in the Venn diagram, how it's related with words, and also how we relate it with symbols. Make sure you examine that clearly and closely.